The unicorn, closest black hole to Earth ever discovered. Scientists have discovered one of the smallest black holes on record and the closest one to Earth found to date. Researchers have dubbed it the unicorn in part because it is so far one of a kind and in part because it was found in the constellation Monoceros, the unicorn. The findings were published on April 21st, 2021 in the journal Monthly Notice of the Royal Astronomical Society. Before that, what is black hole? A black hole is a region of space from which nothing, even light, can escape. According to the general theory of relativity, it is the result of the curving of space-time caused by a huge mass. Around a black hole, there is a position of no return called the event horizon. It is called black because it absorbs all the light that hits it, reflecting nothing, just like a perfect black body in thermodynamics. When we looked at the data, the black hole, the unicorn, just popped out, said lead author Tarendra Jai Singh, a doctoral student in astronomy at the Ohio State University and an Ohio State Presidential Fellow. The unicorn is about 3 times the mass of our Sun, tiny for a black hole. Very few black holes of this mass have been found in the universe. This black hole is 1500 light years away from the Earth, still inside the Milky Way galaxy, and until Jason started analyzing it, it was essentially hiding in plain sight. The black hole appears to be a companion to a red giant star, meaning that the two are connected by gravity. Scientists can't see the black hole. They are, by definition, dark not only visually but to the tools astronomers use to measure light and other wavelengths. But in this case, we can see the black hole's companion star. That star had been well documented by telescope system including KELT, that is KELT, run out of Ohio State ASAS, the precursor to ASAS SM, which is now run out of Ohio State, and TESS, a NASA satellite that searches for planets outside our solar system. Data about it had been widely available but hadn't yet been analyzed in this way. When Jai Singh and the other researchers analyzed that data, they noticed something they could see appeared to be orbiting the red giant, causing the light from the star to change in intensity and appearance at various points around the orbit. Something they realized was tugging at the red giant and changing its shape. That pulling effect, called tidal distortion, offers astronomers a signal that something is affecting the star. One option was a black hole, but it would have to be small, less than 5 times the mass of our Sun, falling into a size window that astronomers call the mass gap. Only recently have astronomers considered it a possibility that black holes of that mass could exist. When you look in a different way, which is what we're doing, you find different things, said Chris Stanek, study co-author, astronomy professor at Ohio State and University distinguished scholar. Tarendra looked at this thing that so many other people had looked at, and instead of dismissing the possibility that it could be a black hole, he said, well, What if it could be a black hole? That tidal disruption is produced by the tidal force of an unseen companion, a black hole. Just as the moon's gravity distorts the Earth's oceans, causing the sea to bulge towards and away from the moon, producing high tides, so does the black hole distort the star into a football like shape, which one axis longer than the other, said Todd Thompson, co-author of the study, chair of Ohio State's Astronomy Department and University Distinguished Scholar. The simplest explanation is that it's a black hole, and in this case, the simplest explanation is the most likely one. The velocity of the red giant, the period of the orbit, and the way in which the tidal force distorted the red giant told them the black hole's mass, leading them to conclude that this black hole was around 3 solar masses, or 3 times that of the Sun. For about the last decade, astronomers and astrophysicists wondered whether they weren't finding their black holes because the system approaches they used were not sophisticated enough to find them, or they wondered did they simply not exist. Then, about 18 months ago, many of the members of this Ohio State research team, led by Thompson, published a scientific article in the journal Science, offering strong evidence that these types of black holes existed. That discovery motivated Jaising and others, both at Ohio State and around the world, to search in earnest for smaller black holes. And that evolution led them to the unicorn.